this function h of x, and I have this function g of x, and it's drawn in such a way that h of x is greater than or equal to g of x. The y's of h are greater than or equal to the y's of g. Does that make sense? And there could be a hole here. They may not intersect. Because if there's a hole, there's still a limit. Okay, would you agree? Okay, everybody okay on that? All right. So I have a case where I have another function, f. This is f of x.
So you just draw a squiggly line?
Yeah, just make sure it's in between h and g. Okay? And so I have this situation that g of x, its y's, are less than the y's of f of x, which is less than the y's made by h of x. So it's in between there. And if the limit of g as it approaches c is equal to L, and the limit as x approaches c of h of x is also equal to L, what has to be true is the limit of f of x as x approaches c, it also must equal L. And that kind of makes sense. It's being squeezed. Those y values of g and h are squeezing it towards L as we're approaching c from the left and the right. Does that make sense? And so this is the official squeeze theorem. If g of x is less than f of x, and f of x is less than h of x, then, and if both of those have the same limit at c, then that one that's in between has to have that limit. That's what it's saying. Okay? I asked you to state that on the quiz, and since this is your notes, you can simply copy it from these notes. Okay? So let's take a look at this right here. I'll give you an example. Okay? First thing I'm going to do is I'm going to take the cosine of 1 over x squared. Now, the reason I chose cosine is bounded. Its y's are bounded. The biggest, what I mean by that, if you ever look at cosine, its y's go up and down, correct? But they're bounded by two numbers. What are those two numbers? What y values is this bounded by? One and?
Negative 1?
1 and a negative 1. So I know that this function is between 1 and a negative 1. Guaranteed. Now notice, this right here is what I'm taking the limit of. It's a product, isn't it? So I can multiply this by x squared. I can multiply this by x squared.
I'm just trying to write along. I'm not even following along, which is unfortunate.
And I can multiply that by x squared. And I don't have to change directions because x squared is always positive, correct? So now I have this function.
Which I don't even follow along.
Okay, I'll back up. Are you okay that cosine is bounded by negative 1 and 1?
Yes.
Okay. All I did here is do some algebra. I multiplied a negative 1 by x squared. I multiplied this cosine by x squared, and I multiplied 1 by x squared. I want to figure out its limit, and I want two functions that I want it bounded by.
How did you multiply that stuff?
What?
How did you get to multiply that stuff?
Agree?
Mm-hmm.
If I multiply this by 2, if I multiply this by 2, if I multiply that by 2, now I got 10 is less than 20 is less than 40. That's still true, isn't it?
Yep.
Okay? And since I'm multiplying by x squared, I don't have to worry, the inequalities remain true. Okay?
Okay.
Okay. So what I'm trying to do is I'm trying to get a g of x and an h of x, and I'm gonna figure out those limits. I can't figure out this limit. I don't have a way to do that. So I wanna bound it by something. I initially say, hey, anytime I got sine and cosine, I can bound them by -1 and 1, right? And then I can multiply by something to find two functions. So I'm gonna take the limit of this of a negative x squared. That's a pretty easy limit to figure out, isn't it? What's that limit? 0. And then I'm going to take the limit on the one on the right side. That's an easy limit to figure out. That's got to be what?
0.
0. So what is the limit of this? What must it be?
0.
Exactly correct. I'll give you another one. Is there nothing on this side?
Nope.
No, I'm gonna wait with that. That's not what, I don't wanna do that. No. All right, let's take a look at this. It says, let g and h be the functions defined by g of x is a negative x squared plus 2x minus 3, and h of x is 2x plus 1. If f is a function that satisfies g of x is less than or equal to f of x is less than or equal to h of x for all x, what's the limit of f of x? So it's telling you, you don't know f, but you know this one, and you know this one. And you know that f is in between g and h, correct? So what I'm going to do is I'm going to take the limit as x approaches 2. Where did I get 2? That's what I'm trying to figure the limit of f at. And I'm going to do g of x first. Now, this is typical AP. If they give you what g of x is, you don't have to continually write a negative x squared plus 2x minus 3. Because they told you that, all right? And that limit is what, Jonah?
Is it -3?
I got a -3. I get 2 squared, which is 4, -4, plus 2 times 2, which is 4. That gives me 0, minus 3 gives me a -3. This one better be a -3 also, so I'm going to take the limit as x approaches 2 of h of x. What do I get? What don't I get? I don't get -3, do I? I get what? 5. So what does that mean? Limit cannot be determined. Let's look at this one. Let g and h be the functions defined by this. if f is a function that is in between those two for the interval -1 to 5, what's the limit of f of x at 0? So I'm gonna first figure out the limit as x approaches 0 of what, Ben?
G of x and h of x?
G of x, I'll do g of x first. That's the smallest one, right? That's to the left.
Yeah.
So I could put 0 into cosine. I get pi over 2 times 0, that's 0. Okay, now here's the hard question. Okay? What's the cosine of 0?
0?
Pardon?
Is it 0 or 1?
Well, it's one of those two. It's like a true-false question.
Yeah.
Cosine is
I
x.
think it's 0.
It's 1.
Shoot.
Okay, don't worry. They'll come back. I'll ask it again another time. So it's 1 plus 2, I get what here?
3?
3. And then you were right. The limit as x approaches 0 of h of x, and I'm going to put 0 into here, or you are, correct? And you're going to get
3?
3. Therefore, and this is how math people spell therefore.
It's so much more easier. Can I do that in all my other classes?
I can only speak about this class.
And,
Therefore,
well, then I'll send them to you if they find it wrong.
pardon?
Well, then I'll direct them to you if they don't like
Okay,
it.
that's fine. The limit as x approaches 0 of f of x, Ben, is what?
3?
3. All right, so it says, number 4, says let f, g, and h be the functions defined by f of x equals 1 minus the cosine of over 2 of x. G of x is x cubed sine of x over 1. H of x is x over the sine of x for x not equal to 0. All the following inequalities are true for x not equal to 0. State whether each inequality can be used with the squeeze theorem to find the limit of the function as x approaches 0. So, the first thing I'm going to do, it says -1/2. The limit as x approaches 0, -1/2. This is g, isn't it? It's to the left.
I cannot see what you're writing down there.
Okay? Audrey, what is that? -1/2. Then I'm going to figure out the limit as x approaches 0 of x squared plus 1/2. What do I get, Audrey? 1/2. They're not the same, are they? No, we can't determine the limit as x approaches 0 of f of x. Colin, what's the first thing I'm going to do? I want to determine if I can figure out the limit of this one. I can't hear you at all.
Okay.
I hear the fan.
Okay.
I got the limit as x approaches 0 of what?
Negative x cubed.
Negative x cubed. What is that?
0.
0. The limit as x approaches 0 of x cubed.
That's also 0.
That's what?
That's also zero.
Okay? Therefore, the limit as x approaches 0 of g of x is equal to what?
Not 0. It cannot be.
Why?
Because it says so in the problem.
It says, remember, it's what it's approaching. It's not what the value is. So it's saying f of 0 doesn't exist, but what is that, or excuse me, g of 0 doesn't exist, but what is it approaching?
It also cannot work due to the fact that the lines under the inequality signs. In my personal opinion. Well, hey, I could be.
No, it doesn't. It says or equal to. It doesn't have to be equal to, but it could be equal to.
Okay, then I guess you were correct and I'm wrong.
Okay, I'll go with that. Colin, what's the answer?
Zero.
0. And if you take a look at this, this is very similar to the one that I did in the beginning. I would start with sine. Sine is bounded by -1 and 1, correct? I could multiply everything through by an x cubed. I'd have a negative x cubed and a positive x cubed. I could figure out the limits of those. They'd be 0. And so that would have to be 0. Does that make sense? Looks just like this one right here. Except the only difference is this is the sine, and over here this is x cubed. Okay?
I was not listening about that. What did you say again?
Okay, so this is the example I did at the very beginning.
Okay.
Well, if I had replaced cosine with sine, it would still be bounded by this. Okay? And rather than multiply by x squared, I could multiply by x cubed, and I would have x cubed, negative x cubed here, x cubed here, sine here, x cubed here. Still do the limits of a negative x cubed and x cubed, like I did here. Its limits would be 0. So this, g of x, which is this, would also have to be 0. Again, it's what it's approaching. All right, Callan, how am I going to start here?
The limit as x approaches 0. I did negative x squared plus 1.
Or 1 minus x squared?
Minus x squared.
Okay, what do I get?
1.
What about the limit as x approaches 0? What's the next one? X squared plus 1?
Yep.
What do I get there? 1. Therefore, what has to be true?
Limit as h of x. Limit as x approaches 0 of h of x is 1.
Now that's one that I gave you as an identity, correct? Remember that? Okay, so I'm going to throw this on my calculator. And I'm going to put in 1 minus x squared. I'm going to put in x squared plus 1. I think I could draw it. And there they are, correct? You can see the red graph is above the blue graph. I'm going to put in x divided by the sine of x, which is green. I'm going to draw it. Okay, now, the only place, I'm not worried about any of this other stuff that's out here. Remember, it's as x is approaching 0. So once I start getting really, really close, this green line is being squeezed by the red and the blue, correct? And it's going to be approaching the same value, which is 1. Does it make sense?
I guess it finally does.
Okay. What if I had this? And thought about it, I don't even know if it works. The sine of x, I think I got to put in parentheses, divided by x. Same thing, right?
Different graph for
Okay.
the middle bit, but still the same result of as x approaches 0.
Right. Everybody agree with that? So that is how, if you find two functions, you can say, okay, here's their limits. That's how those special trig ones were defined. Does that make sense to everybody? All right. All right, and this is the last of the notes for before the test. And the notes are really, really short. And these are kind of like AP questions, notes. All right, so on this one, there's gonna be a couple of representations. Again, it's kind of like, okay, what if we don't have any algebra we can do? And when I first started teaching AP, that was the hardest part for students, and it may be for you, because we have all these, we have the quadratic formula, we factor, we all have this algebraic manipulation. And we really don't, we struggle if we have tables or graphs or some other form, okay? And so that's that analyzation place. So the first one says, if f is a piecewise, and I always underline some things because trying to figure out, I remember a number of students said yesterday, trying to figure out what's being asked of me, I struggle with that. And I gotta turn this up a little bit because it's not seeing what I need to see. So I'm underlining the word linear function. Okay, so when I think of that, it's got slope, correct? And I want to, if f is a piecewise linear function such that the limit does not exist as it approaches 5, which of the following could be that function? So what they're doing is, you've been doing problems, find the limit, find the limit, find the limit, and now they're saying, okay, you got f, and it doesn't have a limit, and I have these 3 forms. Which of them doesn't have a limit of, for f? Well, this is piecewise. This is table. And this is graph. And I never do my problems in order. When I take any exam, I do all the problems I know the answer to first. And then I go back and say, okay, I kind of knew this, and I work on the ones I kind of know, and then the ones I don't know, I do last. For me, I do that as a confidence booster, because I know at least, the first problem I do that I get correct every single time is I put my name on a piece of paper. Okay. Because when I got to college, all of a sudden I started getting test anxiety, and I'm going, okay, I'm a math teacher, I'm gonna be taking a lot of math tests. I cannot be freezing up when I take a math test. So I had to go through a process so I could go through the problems, and that's how I solved that. So I would start with C. Now again, the question is, which of the following could be a representation of f which does not have a limit at 5? Does f not have a limit at 5 on C, that graph? So this is yes. The limit as x approaches 5 of f of x does not exist. The limit as x approaches 5 from the left of f is not equal to the limit as x approaches 5 from the right f of x. Now, why did I put this in here? They do not ask you to justify, but if they did ask you to justify, that's my justification. All right? The next one that's easiest for me to do is this. So I can substitute 5 into both of these. Now, I know it doesn't exist, so there's a hole there, correct? So what I'm going to do is I'm going to take the limit as x approaches 5 from the left. That means I'm going to use 2x minus 1, and I'm going to get, I think, 9. Does that look correct? And then I'm going to take the limit as x approaches 5 from the right of 14 minus x, and I get 9. So I know the limit as x approaches 5 of f of x. It is 9, correct? Maria, I love it that you're shaking yes, because it's the same as it is from the left and the right, isn't it? So can this be f? F can't have a limit. Is this f? No, it has a limit. So the answer here is no. Remember, you want an f that does not have a limit at 5. This has a limit at 5, it's 9. So this can't be it. This one, I think, is the hardest. Okay. Notice this. As I'm approaching 5, my points are, and it's linear. Remember, this is linear. So as I'm approaching 5 from the left, my points are 2, 10, 3, 8, 4, 6, 5, 1. That means I have a slope of what?
-2 over 1, so -2.
-2. Okay? Now, so it means the limit as I approach 5 from the left of f of x, I went 2, 10, 3, 8, 4, 6, it should be 5 what?
4.
4. Now, there's a 1 there. Well, this could be an open circle, correct? With a dot at 5, 1, right? Everybody see that? So if I were to draw that graph right here, here's 5, here's 1, it's dropping. I have an open circle at 4 like this, correct? Now, let's take a look at the right. 8, 16, Well, it goes 6, 6, 7, 11, 8, 16. That also has a slope. What is its slope? 5. So that means that the limit as x approaches 5 from the right of f of x would be, well, it would be 8, 16, 7, 11, 6, 6, it would be 5 what? 1. So it means this way it's going like this, correct? Would everybody agree? So this would be 1. So the question is, the limit as x approaches 5 of f of x, what would your answer be?
D and E.
D and E, because they're two different numbers. My justification would be the limit as x approaches 5 from the left of f of x does not equal the limit as x approaches 5 from the right of f of x. Any questions on those three?
I think I understand it.
Okay, now, I'm making this bigger. Owen, give me some specifics. What do you know about this function?
You can't just plug 4 into it, it's 0.
Correct. What do you know about the thing on top?
Absolute value.
Absolute value.
Positive.
Your answer is always going to be positive, correct? You're approaching from the left, correct?
Yeah.
Okay. Give me a number that's to the left of 4.
2.
Okay. I'm going to tell you why 2 is not a good number. Because it's not close to 4. And we want to be close to 4, right?
Okay. Negative or 3.5.
3.5 is closer, okay?
0.9.
You know, and I know 3 is my favorite number, but 3 would not be a good choice because it's too far away.
3.999.
3.999. Well, we'll go 3.5. Okay? So if I put I can put a 3.5 up here, correct?
Yeah.
What will I get? So let me just write a little table here. And you said put in 3.5, correct?
Yeah, so 0.5.
So what do I get on top?
0.5.
What do I get on the bottom?
Negative 1.
Negative point what?
Negative 1.
Okay, on the bottom be a negative 0.5. 0.5 divided by a negative 0.5 is a negative 1. Is that what you're telling me?
Yes.
Yes. Okay, very good. Okay? Would everybody agree?
Mm-hmm.
So, I will use yours, okay? But I'm gonna choose the number before I get to yours, okay? I'm gonna choose 3.9. And Owen, the reason I chose 3.9, it's an easy number, but it's closer. Okay? Positive on top. A positive 0.1, would you agree? Negative on the bottom, because I don't have the security of the absolute value, correct?
Right.
A negative, they're opposites, aren't they? Would everybody agree? So I get 0.1 divided by a negative 0.1, which is a negative 1. Okay? Now, Matthew, I think this is what you said.
The limit is negative 1.
Would you agree? Okay, now, so when you have absolute value ones, okay? To the left it'll be a -1. What do you think it would be if it was to the right?
+1,
Why?
because it won't be negative in the bottom anymore.
Do you agree?
You,
Okay. Now, I'm gonna draw a graph of this. 1, 2, 3, 4. I'm not gonna draw a graph of that. I'm gonna draw a graph of the absolute value, okay? So I'm drawing a graph of f of x equals the absolute value of x minus 4. So right here is 4. This is 4. This is 8. This would be 4. That's what it looks like, a V, correct? Right? So this point is 4, 0. Would you agree with that, Jonah?
Yep.
This point is 0, 4. Would you agree with that?
Yep.
What's the slope of this side of the absolute value graph?
-1,
What's the slope on this side?
1.
We'll come back to that. Okay. Would everybody agree with that? Okay. Good. All right, that is it. So I'm gonna give you your assignments. Rest of the time is work, tomorrow is work. I gave you this already. You don't need the purple, right? I gave you this assignment, right? Did I give you this?
what time was it?
No.
What was it called? What was that assignment called?
It is called,